If I handed you a massive pile of lumber, some copper wire, a pallet of bricks, and a toolbox, and just told you to build a house, you would probably just stare at me.
Yeah, I mean, I definitely would. Or I'd build a shack that collapses.
Right, you would completely fail. Yet, when we decide we want to learn something incredibly complex, whether that is Python programming or a new language, we essentially do exactly that. We bookmark 50 different articles, we buy 3
Oh,
textbooks.
yeah, and subscribe to a dozen YouTube channels.
Exactly, and we just stand in the middle of all this raw information expecting a coherent syllabus to, like, organically build itself in our brains. So welcome to today's deep dive. Our mission today is to completely fix that broken approach.
We are looking at a highly optimized two-sentence AI prompt. It's titled Architecting the Grammar Mastery Roadmap. And it is just a remarkable piece of constraint engineering.
It really is. On the surface, it looks like a simple query, but it is actually this foundational framework designed to force a large language model to, well, stop acting like an encyclopedia.
Right, and start acting like a master curriculum designer. It completely rewrites the relationship between you, the learner, and that vast ocean of data you are trying to absorb.
Okay, let's unpack this because the core concept from our source material is established right out of the gate. The document outlines a very specific request to feed into an AI.
It asks to be taught a subject. The placeholder it uses is, what is grammar?
Yeah, and the very first command is demanding to be taught this, using the best learning order. It explicitly doesn't just ask for a list of facts, it demands a structural path.
And what's fascinating here is the specific use of the word architecting in the source's title. That word choice signals the entire philosophy of this framework.
Because it isn't called, like, reading the grammar mastery roadmap.
Exactly, or observing the grammar roadmap. Architecture implies deliberate, calculated design. I mean, a structural engineer doesn't just throw drywall and glass together.
No, they calculate load paths.
Right. They understand that the gravitational force applied to the roof has to be carried down through the studs, into the joists, and, finally distributed into the concrete foundation. If they get that sequential physics wrong, the whole building collapses.
It just falls under its own weight.
Yeah.
And the source document is demanding that we treat living a new subject with that exact same level of structural rigor. Which brings us to that first massive command in the source text, establishing the best learning order.
And this connects perfectly to that architectural load path you just mentioned. You obviously cannot put the roof on before the foundation is poured.
Right, but I have to push back on this a little bit. The prompt demands the AI create a step-by-step roadmap from beginner to advanced. It demands a single best order.
You think that's too rigid?
I do. I mean, is that actually a realistic expectation for something as subjective as human learning? I see the logic for a computer or a building, but human brains are so incredibly diverse. Like, some people are visual learners, some are tactile, some like to jump around and explore. Isn't demanding the one best learning order a bit, I don't know, rigid?
It is a crucial point of friction. But we really have to separate learning style from structural dependency. The prompt isn't dictating how you ingest the information.
Okay, so I can still use flashcards or watch videos.
Exactly. You can draw diagrams all day. What it is dictating is the chronology of concepts. Let's look strictly at the source's demand for a beginner to advanced roadmap.
Why is it so strict?
Because while your preferred style of studying might vary, the structural dependency of the information does not. You cannot mathematically comprehend multiplication without first understanding addition. It is structurally impossible.
Oh, I see. So it's about the prerequisites built into the fabric of the subject itself.
Precisely. And when you look at how large language models function, this constraint is vital. If you just ask an AI to teach you grammar, it searches its vast latent space.
And usually spits out a scattershot list of the most popular topics, right?
Yeah, you just get a bulleted list of random rules. But by forcing the AI to output the best learning order from beginner to advanced, you are forcing the model to map its own knowledge base chronologically.
You force it to calculate those load paths.
Exactly. And this dramatically reduces AI hallucinations because it forces the system to verify the logical sequence of its own output. Furthermore, it removes the burden of curriculum design from the learner entirely.
Because when you are a beginner, you suffer from the illusion of choice.
You really do. You don't actually know enough about the subject to know what you need to learn next.
You are so right about the illusion of choice. I want you, listening right now, to think about your own learning experiences. Think about a time you picked up a new, complex hobby.
Like coding, maybe.
Yeah, let's say coding. You download some software, and instead of learning basic syntax, you find a YouTube tutorial for some crazy, complicated machine learning script.
We have all been there.
You copy the code, it throws an error, and you end up completely frustrated. You get convinced that you just don't have the brain for programming. But this roadmap from our source strictly forbids that kind of skipping.
It forces you to respect the dependency of the information. And by respecting that dependency, you're optimizing your own cognitive load.
Right, because cognitive load theory dictates that our working memory has strict limits.
Exactly. When you jump to an advanced topic without the foundational context, your brain experiences a massive spike in what is called extraneous load.
You are trying to simultaneously memorize the new, complex concept while desperately trying to guess the missing foundational pieces.
It's completely overwhelming.
Hmm.
The beginner to advanced roadmap ensures that your brain only ever has to process one new layer of difficulty at a time. The concrete is already dry before you try to stand on it.
Which naturally leads us to the next massive challenge. It is one thing to have an AI generate a beautifully sequenced map.
Sure, but an order is useless if the learner just speeds blindly through it.
Exactly. Nodding along, thinking they understand it just because they read the words.
Yeah.
How do we build speed bumps into this learning path?
How does the framework actually prevent you from rushing?
Right. That leads directly to the source's strict rule for progression.
This is the mechanism that elevates the prompt from a simple syllabus generator to a rigorous pedagogical tool. It installs a mandatory gatekeeper at every single step.
The source text has this incredibly vital instruction. It explicitly tells the AI, for each step, explain what I must understand before moving to the next level.
It's brilliant.
Here's where it gets really interesting, because if we think about this in modern design terms, it is exactly like the tech trees in a deep strategy video game.
Oh, I love that analogy. Like Civilization.
Yeah, or any Metroidvania-style game. You simply cannot research spaceflight before you have discovered combustion.
Yeah.
You cannot open the heavy titanium door until you have acquired the laser upgrade 3 zones prior.
The game's architecture physically blocks you from progressing.
Exactly.
And game designers do that deliberately. Not to punish the player, but to ensure the player actually has the mechanical tools necessary to survive the later stages of the game.
Right. It's for your own good.
If we unpack the educational philosophy behind this constraint in the prompt, it completely shifts how we measure success. In a traditional classroom, progression is often tied to the calendar,
You complete a stage simply because Tuesday turned into Wednesday.
or because you sat through a 45-minute lecture. You progress by merely existing in the room.
Right. The seat time model of learning.
Exactly.
Mhm.
But this document rejects that entirely. By forcing the AI to define what must be understood before moving on, the framework builds in a self-diagnostic tool based purely on mastery.
It forces you, the learner, to stop and self-evaluate.
You have to look at the prerequisite the AI generated and ask, wait, could I actually explain this concept to someone else right now?
Or did I just passively skim the paragraph? It transforms the journey.
It really does.
For you listening, this is your ultimate safeguard against the anxiety of information overload. You are literally not allowed to move forward until you comprehend the current checkpoint.
It completely removes the guilt of feeling like you aren't moving fast enough, because speed becomes a completely irrelevant metric.
Comprehension is the only currency that matters.
To borrow a concept from developmental psychologist Lev Vygotsky, this mechanism keeps you perfectly within your zone of proximal development.
That is the sweet spot where a task is just difficult enough to challenge you, but not so difficult that it breaks you.
Exactly. If you look at why learners abandon complex subjects, it is almost always because a foundational flaw was ignored. They moved forward anyway, and the weight of the advanced concepts eventually crushed their weak understanding.
That one sentence in the prompt, explain what I must understand before moving to the next level, is the structural inspection.
It forces the AI to output testable parameters so you can guarantee your foundation can hold the weight of tomorrow's lesson.
Okay, so we have dissected the abstract architecture, the chronological mapping, and the strict progression gates. But our source material does not leave this in the realm of theory.
No, it takes this powerful framework and applies it to a notoriously dense, real-world example.
Yes, and seeing the prompt fully assembled gives us a much clearer picture of how these variables interact.
It really shows how it generates a highly functional output from an AI.
Let me read the specific example provided in the text. It says, teach me English grammar in the best learning order from beginner to advanced.
There is our core load path command.
Then it continues, create a study roadmap, explain what I must understand before moving to the next level.
And there is our progression gatekeeper.
But then it adds one final clause. It says, and explain the purpose of each stage. So what does this all mean?
It's a great question.
Why did the example introduce this completely new requirement right at the end? Why does the AI need to explain the purpose?
If we connect this to the bigger picture, the addition of the purpose parameter is the secret ingredient. It's what makes this entire structured architecture actually habitable for a human being.
Think about the mechanics of learning. Knowing what you must understand, like the syntax or the rules, is completely detached from knowing why you are learning it.
And let's be honest, English grammar, much like early stage programming or complex mathematics, can be incredibly dry in the beginner stages.
Oh, absolutely. You are memorizing verb conjugations, identifying dangling modifiers, diagramming sentences.
If the AI only gives you the what, it feels like endless, meaningless administrative labor.
It feels like being told to memorize the phone book. It is just raw data without context. I'd argue this is where the system risks killing the learner's passion entirely.
Without a doubt.
If I am forced to sit at stage 1, gated from moving forward until I memorize 50 grammar rules, I might just quit out of sheer boredom.
Which is exactly why the purpose clause is brilliant. Defining the purpose provides the learner with a psychological motivation required to push through that extraneous cognitive load.
It maps the abstract rule to a tangible, real-world utility.
Let's role-play this to see how it alters the AI's output. If you run this prompt without the purpose clause for English grammar, stage 1 might be, learn subject-verb-object sentence structure.
Cold, clinical, boring, just a textbook heading.
But when you force the AI to explain the purpose, it changes the output to something like stage 1, subject-verb-object structure, purpose, to ensure you can express a complete, autonomous thought without ambiguity, allowing you to clearly state who is doing what.
Wow. Suddenly the labor has immense meaning.
You aren't just memorizing syntax. You are unlocking the ability to be clearly understood by another human being.
Let's jump ahead in that role play. Imagine we are at stage 5 of this AI-generated grammar roadmap and we hit the subjunctive mood.
Oh boy, the subjunctive mood.
Right. The prerequisite gatekeeper kicks in and says, before moving to the next level, you must flawlessly identify standard verb tenses and dependent clauses. That is a massive wall to climb.
It is, but then the purpose clause kicks in.
Exactly. It tells you the purpose of mastering the subjunctive mood is so you can express hypothetical scenarios, deep desires, or conditions that are contrary to fact.
It tells you that the subjunctive mood is the tool you need to dream out loud. It is the grammar of imagination.
Yes, it provides the emotional stamina required to reach the advanced level. Because nobody learns a complex subject just because they love the beginner drills.
Well, and you learn the tedious finger scales on a piano because you desperately want to eventually play a beautiful sonata.
You learn the rigid rules of grammar because you want to write a persuasive argument or a beautiful poem or, just tell a really great joke.
The purpose parameter is the beacon you keep your eyes on when what gets overwhelmingly difficult.
It ensures the AI connects every single granular rule back to your ultimate human goals.
And that highlights a profound truth about instructional design. Human beings are not just data processing algorithms.
We require logical structure to prevent cognitive overload.
Which is why the prompt demands the best learning order and strict prerequisites. But we fundamentally require meaning to sustain attention.
Which is why it demands the purpose. The prompt perfectly balances the cold structural requirements of the subject matter with the warm psychological requirements of the human learner.
It's an absolute masterclass in prompt engineering.
So let's summarize the three-part architecture of this blueprint we've been exploring. First, you constrain the AI to map the absolute best beginner to advanced order.
Removing your own choice paralysis and forcing the AI to organize its latent space logically.
Second, you demand strict, testable prerequisites for moving to the next level.
Ensuring that genuine mastery, not just reading speed, is your only metric for progression.
And third, you force the AI to clearly explain the purpose behind every single stage.
Providing the motivational context to keep you engaged. And the most actionable takeaway for you, the listener, is the universality of this tool.
It's not just for grammar.
Not at all. While the source text used English grammar as its placeholder, you can take this exact two-sentence string and apply it to literally any domain of knowledge.
But to use it most effectively, you should add your own context, right?
Yes. Before hitting enter, give the AI your starting coordinate. Say, I am currently a B1 level Spanish speaker, or I know basic Python syntax, but nothing about data structures.
Then paste the prompt. Teach me in the best learning order from beginner to advanced. Create a study roadmap, explain what I must understand before moving to the next level, and explain the purpose of each stage.
You are essentially commanding the AI to become a bespoke master architect for your own cognitive development.
You never have to fear that massive pile of raw lumber again, because you now have the exact command required to generate the blueprint. You can navigate any complex system without ever feeling lost.
But this raises an important question, one that pushes against the very boundaries of this highly structured algorithmic approach to learning.
Okay, honestly.
If we perfectly architect this roadmap, if every stage has a defined logical purpose, and if you are strictly gated from moving forward until you flawlessly understand every single rule, does that pristine structure leave any room for the messy, intuitive, and often rule-breaking ways we actually interact with the real world?
Oh, wow, that's a great point.
When we consider the source's example of living language, we know that native speakers break the rules constantly. Slang, poetry, emotional outbursts, cultural idioms, they rarely follow a logical step-by-step roadmap.
They definitely don't.
So can a perfectly engineered chronological blueprint ever truly capture the beautiful, unpredictable chaos of a subject? Or does it only build a pristine, but ultimately artificial, simulation?
That is a phenomenal, provocative thought to leave on, because an architect can design the perfect house, calculate every load path flawlessly, and build the strongest foundation possible using all the right prerequisites. But once the family actually moves in, the furniture gets rearranged, the paint gets scuffed, and the house has to weather the unpredictable storms of the real world.
The blueprint gets you the structure to survive, but the chaos is what actually makes it a home.
Beautifully said. Something for you to ponder as you look at the raw materials of whatever complex subject you are trying to build next.